In 1901, a group of sponge divers were working off the coast of the Greek island of Antikythera when they came across something strange at the bottom of the sea. They weren't sure what to make of it. It was definitely man-made, but it was covered in barnacles and algae. And there it sat for years until someone finally noticed it had some statues, some coins, and a few other artifacts in it. But what really caught their attention was this weird, corroded lump in the middle of it all. It almost looked like a piece of machinery or something, but it was so corroded that no one could tell what it was or how old it was. And so once again, it was forgotten about. But a few decades later, someone else took notice of it. This time they got it scanned with an X-ray machine, and what they found shocked them. There was a series of gears hidden inside the corroded lump. This is the Antikythera Mechanism. The waters here are deep and murky, making it hard to see anything clearly beneath the surface. But somehow these divers managed to spot a large mound on the seafloor. But then they found a marble statue of Aphrodite, the goddess of love and beauty. And this was weird because statues like this were usually only found in museums and private collections. You wouldn't expect to find one at the bottom of the sea. As they continued digging, they uncovered more treasures, including another statue of the god Poseidon and dozens of bronze coins minted between 80 BC and 30 AD. Whoever owned this hoard of treasure must have been incredibly wealthy. But why would they be at the bottom of the sea? That's when the divers discovered a large lump of corroded metal, which didn't look like much. They estimated it weighed about 40 kilograms. It was covered in barnacles and algae and looked like nothing more than a hunk of scrap metal. They didn't realize at the time that this corroded lump contained the world's first known analog computer. To be fair, they probably thought they'd already found that with the statues and the coins. But we'll get into that in just a second. For now, let's go back to the beginning when these statues and coins were actually being used. We don't know exactly where they were from, but we think they might have belonged to a Roman senator named Gaius Cassius Longinus. He was born in Bithynia, a region in modern-day Turkey. In 44 BC, he became part of the Second Triumvirate, a group of 3 leaders who shared power in the Roman world. The others were Mark Antony and Octavian, who later became the first emperor of Rome. Cassius was a cunning politician and a skilled general, but he made the mistake of allying himself with Cleopatra after he murdered Julius Caesar. This ended his political career, and he spent his last years trying to reclaim his power. Unfortunately, he died in 32 BC while attempting to flee the Roman fleet in a small boat. Legend has it he drowned after mistaking salt water for wine. It's entirely possible he had a stash of valuables hidden on this ship that sank with him, although we don't know that for sure. Either way, it's safe to say that whoever owned these items had quite a bit of money. So how did they end up at the bottom of the sea? Well, it's entirely possible that the ship carrying them was lost at sea. Storms can easily capsize a boat and drag its cargo to the depths. But another theory says this was no accident. According to Roman historian Plutarch, Cassius was warned by an oracle that he would come to a bad end if he set sail from the port of Piraeus. He ignored this warning and left anyway, perhaps believing he was invincible. But soon after, a storm appeared out of nowhere and destroyed his fleet. Only one ship survived, but it was never the same after losing so many men and treasures to the sea. This story might sound a little unbelievable, but Plutarch was a respected historian who lived just a century after the events he described. It's entirely possible this is what happened to Cassius and his cargo. But even if not, the fact remains that this corroded lump of metal was discovered alongside them. At the time, nobody knew what to make of it. It looked like a lump of scrap metal and didn't seem to be missing any parts. It wasn't until the 20th century that someone realized it was a sophisticated piece of technology. It took another 19 years before anyone paid any attention to it. In 1920, it was sent to the National Archaeological Museum in Athens, where it sat for another 67 years. Nobody really knew what it was, so they didn't bother investigating further. But in 1988, someone got it scanned with an X-ray machine and their jaw dropped. Inside this corroded lump were 2 interlocking sets of gears made from bronze. These gears were connected to an axle and surrounded by a ring of 36 equally spaced teeth. Scientists estimate that the entire mechanism had around 30 gears in total, but the corrosion had taken its toll, and several were broken beyond repair. We don't know exactly how many years this thing was buried for, but it's believed to be somewhere between 180 and 150 BC. That makes it nearly 2,000 years old. These gears were made by hand and fit together with incredible precision. Even today, engineers are amazed by the craftsmanship. Take a look at this gear. Look how perfectly smooth it is. You can see scratches and dents from where the workers hammered the metal, but it's hard to believe that anyone could make something like this 2,000 years ago. And yet they did. The question is, how? How did they build this machine? What was it used for? And who built it? It turns out this artifact is called the Antikythera Mechanism. It gets its name from the Greek word for gear, which is analogos. And that's because it was the world's first analog computer. Today, computers use binary code to calculate numbers. They work by manipulating bits, which are zeros and ones. This is called digital data. But before computers were invented, people used analog devices. The difference is huge. To perform calculations, the Antikythera mechanism uses dials and pointers. These are analogous to the numbers they represent. A dial pointing to the 15th fret represents the number 15. This is similar to an old vinyl record player. Instead of using binary code, it uses an arm and a needle to move through grooves with various lengths. This is called analog data. The mechanism is about 18 centimeters long and weighs about 8 pounds. It was likely used to predict astronomical positions, eclipses, and perhaps even calendar dates. We know that the mechanism kept accurate track of the lunar cycle. Every gear had its own function, allowing the user to read complex data in simple terms. But it's still not clear how it was built. Scientists know it was crafted in several pieces and then soldered together, but they haven't been able to determine exactly how. We also don't know who built it or why. At the time it was discovered, it was assumed to be Greek. After all, it was found in Greece, and Greek society was known for its incredible engineering achievements. However, more recent research suggests it was actually Roman. Most people believe it was made by a group of Greek-speaking astronomers. During the Hellenistic period, the Greek and Roman worlds were very interconnected. There was a lot of cultural exchange and trade happening between the two societies, meaning it's hard to tell them apart sometimes. Whatever the case, we know that whoever built this device had access to advanced mathematical concepts. They understood the Earth's rotation and the length of each month. They also had the knowledge to manipulate metal and build a sophisticated piece of machinery. And that raises a lot of questions. How did they learn all this information? Where did they get it from? And why did they possess such advanced knowledge? Sadly, we don't know the answers to these questions. It's possible this mechanism was part of a larger device, but unfortunately, we'll never know. It's possible that more fragments will turn up someday. But for now, we're left with more questions than answers. What do you think? Did the ancient Greeks invent the world's first computer? Let me know your thoughts. And don't forget to subscribe if you haven't already. Thanks for watching. What's inside this box may be one of the most extraordinary artifacts ever found. It's incredibly complex. It has moving parts that fit together like a giant puzzle. And it was made over 2,000 years ago by a civilization that we tend to think of as being much less advanced than ours. So what is this mysterious object? How did they make something like this so long ago? And what did they use it for? This is the Antikythera Mechanism. The name comes from the Greek island of Antikythera, where it was discovered in 1902 during a shipwreck excavation. It was found in pieces along with dozens of other artifacts, including a bunch of Roman coins that helped establish its age. But at first, the archaeologists thought it was just some kind of bronze mirror because it was corroded and covered in algae. It wasn't until scientists started cleaning it off that they realized that it was actually a machine. It took several months to clean the rust off the gears and get them moving again. Even now, after over a century of study, we're still not sure how many pieces there are or how they all fit together. But the Antikythera mechanism is known to contain more than 30 interlocking bronze gears, making it the most complicated piece of machinery ever discovered from the ancient world. If you've ever taken apart and tried to put back together an old clock, you know how tricky it can be to get all those tiny gears meshing properly. And this thing has more than 30 of them. We don't know exactly how many there are because no two pieces are exactly alike, and they were all so badly corroded that some of them had broken into fragments. The original number of fragments is unknown because some of them have been lost over the past century. And the sheer complexity of putting this many gears together might not sound that impressive today, especially since we reuse to computers which store their data in the form of ones and zeros and do all their calculations using electricity. But remember that these guys were doing everything by hand with bronze, and that this was over 2,000 years ago. If you want to get a sense of just how difficult this would have been to build, look at some of the comparable clockwork devices that were built during the 18th century. These are things like the first machine to calculate mathematical tables, the first machines to keep time in both seconds and minutes, and the first machines to automatically wind themselves up. These inventions, which seem fairly straightforward to us today, took the best clockmakers in Europe decades to perfect. And yet somehow the ancient Greeks managed to build something even more complicated than any of those on their own without any modern tools or knowledge of things like ball bearings or other advanced materials. If you want to get a sense of the sophistication required to build something like this, imagine trying to make a clock while using only Stone Age technology. That's basically what these guys were doing. So the next question is, why would they go through all this effort? What was the point of building such a complicated machine? Well, that's a bit of a mystery too. The answer, however, is probably hidden on the device itself, because the Antikythera Mechanism was covered in inscriptions, which gave us some hints about what it was used for. Unfortunately, we don't have a full translation of those inscriptions, but there's enough that we can get a general idea of what it does. In fact, the entire project of deciphering what the Antikythera Mechanism does began with a pair of astronomers who wanted to figure out what those inscriptions meant. They realized that the inscriptions were written in Greek and that they were giving clues about how to use the device for calculating astronomical positions. Those astronomers were George H. Darwin and his son Sir Arthur, and they published their interpretation of the inscriptions in 1908. Ever since then, researchers have been slowly unraveling more and more of its secrets, which revealed that this device was some kind of a tool for making astronomical calculations. But that still doesn't tell us what it actually did. To figure that out, researchers turned to another famous ancient Greek, Archimedes. He was a mathematician, inventor, and astronomer who lived in Syracuse, Italy around the same time the Antikythera Mechanism was made. And he wrote a lot about celestial motion, including a method for calculating the date of lunar eclipses. Researchers noticed that the number of teeth on some of the gears matched the numbers that appear in Archimedes' writings. With that, they were able to determine that the Antikythera Mechanism was used for tracking the phases of the moon, something that the ancient Greeks would have used to predict eclipses. But it was a few decades later when someone discovered that the device was also being used to track the motion of 5 planets, including the Sun. So this little device could track the position of the moon and the planets in the sky. It could also show the dates of significant astronomical events like lunar and solar eclipses. So if that's what it did, what does it say about the people who built it? Well, to start, it shows that whoever built the Antikythera Mechanism had a really good understanding of the universe. They knew that the sun, moon, and planets moved in cycles, and that these cycles could be used to predict future positions and eclipses. They also had to know a lot of math to come up with all these gear ratios. In fact, some researchers argue that it would have taken the equivalent of 100 PhD students working full-time for 100 years to come up with all the gear ratios needed to make this work. That means that someone would have had to have developed all the necessary mathematical concepts that we use today, like trigonometry. It was also a remarkably sophisticated piece of engineering. Not only did it require an understanding of complex gear ratios, but it also had to be very precise. The gears had to be cut perfectly, and the tolerances between them had to be extremely small. Even the thickness of the metal had to be just right, or the whole thing would get jammed up. Despite this complexity, though, the Antikythera Mechanism is believed to have been made by a single craftsman. It wasn't the product of a huge workshop with hundreds of workers. And that raises another obvious. Who was the craftsman? Well, we don't know who made the Antikythera Mechanism. We don't even know if more than one person was involved in making it. But we do know that it was made in Greece sometime before the year 100 BCE. At that time, Greece was ruled by the Roman Empire, but it was still culturally Greek. So whoever built the Antikythera Mechanism, they were part of this last hurrah of Greek culture before the Romans completely took over. Unfortunately, we don't know anything else about them. There are no surviving records and no archaeological evidence. It's possible that the craftsman's name was lost to history, but it's also possible that they weren't a famous craftsman at all. After all, we have no evidence that they were even credited with inventing this in their own time. Some researchers believe that the Antikythera mechanism was built by someone named Ctesibius, who was a Greek engineer and inventor from Alexandria. Most of what he invented has also been lost to history, but he is credited with inventing the astrolabe, which is a handheld device used for making astronomical calculations. We don't know if Ctesibius was the one who built the Antikythera mechanism, but it seems likely that he built something similar to it. Either way, though, we will probably never know who built it or what happened to them. All we know is that they created one of the most extraordinary artifacts ever discovered. When researchers realized that the Antikythera mechanism was a sophisticated calculating machine, it forced them to completely rethink history. Before they discovered the Antikythera mechanism, experts believed that the Industrial Revolution was the first time that humans really started using machines to do calculations for them. That's because they believed that the concept of a machine that could perform calculations was too complicated for the ancient Greeks or Romans to figure out. They didn't know how to write computer code or even how to build basic mechanical components like gears. And that meant that they didn't think that the ancient Greeks or Romans could have built a mechanical analog computer. But once they realized that the Antikythera mechanism was an analog computer, they had to rethink the entire history of technology. Suddenly, it seemed much more plausible that the Industrial Revolution had happened gradually rather than suddenly. It showed that the ancients already had a concept of using machines to do calculations for them. And that meant that the leap from there to the modern computer wasn't quite so big. The Antikythera mechanism is currently held in a museum in Athens, and it's one of the most popular artifacts there. It's also one of the most mysterious, and we're probably never going to know everything about it. That's because some of the mechanisms are still not fully understood, and new discoveries are still being made. For example, researchers recently discovered that the pointer on the eclipse indicator moves twice as fast as the pointers on the calendar wheels. And that suggests that the Antikythera mechanism could also be used as a sundial. If that's true, it suggests that the device was even more versatile than we thought. Researchers are also continuing to search for other artifacts like it. After all, if someone was willing to go through all the trouble of building one of these, they may have built more than one. Maybe they built a whole series of these devices, each one more sophisticated than the last. So far, though, they haven't found any others. The only thing they've found is a few gears and fragments that may have come from another Antikythera mechanism. When most people think of ancient civilizations, they imagine great architectural achievements, impressive pyramids, and giant statues. However, they don't usually associate these cultures with advanced technology or engineering skills. Most people believe that basic tools and rudimentary machines were about as complex as the technology got back then, and anything more sophisticated was usually written off as a myth. The general consensus is that it was until the Middle Ages that mechanical engineering started to take off. Even then, it was mostly limited to Europe, where the scientific method had just started taking root. However, this belief might not be entirely accurate because the ancient Greeks might have been far more advanced than we thought. They had an uncanny ability to make inventions centuries ahead of their time, and all evidence points to them being so advanced they could put our modern engineers to shame. So here are some facts that prove Greek engineering was more advanced than we thought. Number 6. The Antikythera Mechanism. The discovery of the Antikythera Mechanism has left scientists baffled. This ancient device was discovered in 1902, and it is believed to have been created around 200 BC by the Greek mathematician Archimedes. The mechanism is essentially a complex astronomical calculator that was used to track the movements of the sun, moon, and various planets. To make this device even more remarkable, it is believed to have been created at least 1,000 years before the Mayans invented their own calculating device. The Antikythera mechanism is made up of around 30 bronze gears, but no one knows exactly how it works. Experts say the device had the ability to predict eclipses, and it also allowed users to calculate the date of the Olympic Games, which took place every 4 years in ancient Greece. It could also track the phases of the moon, and it calculated the date of important religious festivals. Historians know very little about the device, but they are almost certain that it required someone with a high level of mathematical knowledge to use it. Some experts say it was so complicated that only a handful of people would have ever known how to work it. Number 5. Gears in antiquity. The Antikythera mechanism is impressive, but it is far from the only piece of evidence that ancient Greeks had mastered the art of gear making. In fact, we found many different examples of gears that date back thousands of years. One of the most interesting examples is the Heron's automata, which is a series of sculptures that were designed to move automatically. These sculptures were created around 100 AD by Hero of Alexandria, who was a Greek engineer and mathematician. The sculptures weren't the first of their kind, but they were incredibly complex for their time period. They worked by using water power to turn a series of gears, which then activated various parts of the sculpture. The sculptures would move in specific ways to mimic human movement. One of the most famous examples is the so-called laughing philosopher, which depicts a man urinating into a basin while a separate figure pours water into a bowl. A third figure then uses a ladle to take water from the bowl and then sprinkles it into the air. The entire process was driven by water power and gears, and it fascinated audiences for hundreds of years. Number 4. Lost knowledge. There is a good chance that ancient Greek inventions like the Antikythera Mechanism were much more common than we think. Unfortunately, all evidence of these devices has been lost to history for one reason or another. Many of them probably just broke down and were melted down for their raw materials. At the same time, others may have been intentionally destroyed. It's well documented that many ancient Greeks were suspicious of new technologies. Anything that threatened to replace traditional jobs or professions was often met with resistance. For example, when the first self-propelled cart was introduced to the public, the Greek populace demanded that it be banned. They claimed it was dangerous and it threatened the livelihoods of charioteers. But their hatred of new technology went beyond just simple protests. They were willing to go as far as destroying entire inventions to prevent society from progressing. When Hero of Alexandria revealed his self-propelled boat, the locals became convinced that it was cursed. They accused him of heresy, and they ultimately drove him out of town. He spent the rest of his life in hiding, and his inventions were never seen again. As you can imagine, this sort of thing greatly slowed the progress of technology in ancient Greece. By the time the Roman Empire rolled around, the Greek Empire had fallen apart, and it seemed like the entire civilization had regressed back to the Dark Ages. Number 3. The legacy of Archimedes. History tells us that the ancient Greek way of thinking had a huge impact on the development of science and engineering. While many inventions were lost to time, there were still plenty of discoveries that stood the test of time. One of the greatest Greek scientists of all time was Archimedes. He was a mathematician, physicist, and inventor who was born in Syracuse, Italy around 287 BC. During his lifetime, he was considered a genius, and he was widely known for his knowledge of mathematics and physics. It is said that he was so brilliant that he once helped King Hiero II of Syracuse design a series of weapons that would help protect the island from invaders. He also devised a way to accurately measure the volume of irregular objects. And he did this by using what's now known as Archimedes' principle. He's also credited with inventing several machines, including a type of crane that could lift heavy objects. He invented a compound pulley system, and he built a type of plow that could easily cut through the toughest of soils. He also made significant advances in the field of geometry, and he is best known for his discovery of the relationship between the area of a circle and its radius. He also determined the value of pi, and he developed a method for calculating the area of a polygon. Number 2. Did they have guns? Around 2,000 years ago, it was common for Greek city-states to go to war with each other. They constantly battled over land and resources, and it led to some truly epic conflicts. But during the Peloponnesian War, things took a turn for the worse. The war was fought between Athens and Sparta, and it lasted for nearly 3 decades. During the conflict, the Athenians used catapults and ballistae to launch missiles at their enemies. Catapults were essentially giant slingshots that could hurl rocks and boulders over long distances. Ballistae were similar to catapults, but they used tension and torsion to launch their projectiles. Both weapons were effective at causing damage, and they were used extensively throughout the war. However, recent evidence suggests the Athenians may have used something even more powerful: guns. Several reports tell the story of a terrifying weapon that looked like a hollow tube and emitted a loud roar. Some historians claim these weapons could shoot solid metal balls that could penetrate enemy shields and armor. We don't have any concrete proof that ancient Greeks used guns, but the writings of Plutarch and Livy suggest that they at least knew how to use gunpowder. Number 1. More to be discovered. All the evidence we've covered so far proves that ancient Greek technology was extremely advanced. But it might not even be the tip of the iceberg. There's a good chance we'll find many more ancient devices in the future that will blow our minds. The truth is, the vast majority of ancient Greece remains unexplored. We've uncovered less than 5% of the country, and there's a good chance we'll find amazing relics from the past if we just keep looking. The reality is, we don't really know what kind of technology ancient Greeks were capable of developing. We only know what they taught us. They purposely kept a lot of their inventions a secret to prevent them from falling into the wrong hands. Ancient Greeks understood the power of knowledge, and they knew that having advanced technology would give them an advantage over their enemies. That's why we have so little information about their culture. They didn't want anyone else to know how advanced they really were. This is the Antikythera Mechanism. It's an ancient Greek device that was discovered in a shipwreck off the coast of the Greek island of Antikythera, and we think it may have been used to predict astronomical events like eclipses. The device dates back to the 2nd century BC, but it was likely built about a decade earlier around the year 200 BC by a man named Archimedes. That's the same guy who gave us Archimedes' principle and also famously yelled Eureka when he found that principle out. He also burned to death while protecting Syracuse from the Romans. Anyway, the Antikythera Mechanism is sometimes called the most complicated piece of technology from the ancient world. So how did it work? Well, let's start with a tour. On the front, there are 2 dials, each with 360 degrees worth of numbers along the edge. These dials track the moon's cycle through the zodiac and the sun's path across the sky during the year. Let's spin them so they line up to the numbers above. Now on the back, we can see 2 more dials which show different things. The upper dial tracks the phases of the moon and also has these 2 red dots. They represent the points of the year when the moon is in its greatest eastern and western elongation, where it's farthest from the sun in the sky. Then there's this huge gear with all these little windows cut into it. It shows us what month it is according to the ancient Greek calendar. The months were named after certain deities and their cults, but I'm pretty sure Zeus would be pretty happy if we renamed the months after him. I mean, it's not like there's a ton of other stuff to name the months after in ancient Greece. You can't call them January, February like we did in school. We didn't invent those names until the Middle Ages. And anyway, we ain't use our regular calendar to tell time with because it doesn't line up with the stars. This calendar will make more sense in a minute. Then on the lower dial, we see these 2 pointers and they point to the signs of the zodiac. And these 2 dials, which have the months on them, they rotate once a year. But the rest of the dial, the really big gear in the middle, that rotates once every 19 years. And this matches up with something called the Metonic cycle. That's the time it takes for the moon to return to the same position relative to the sun, relative to the stars, which is about 668 days or 19 years. And if you want to learn more about why 19 years, then I suggest checking out some videos on YouTube. Why 19 years? Okay, now that we've taken a tour, let's talk about what this thing actually does. The Antikythera Mechanism can tell you all sorts of things about the phases of the moon and the motions of the planets. Like, for instance, right now it's summer here in the northern hemisphere. And if you want to know when winter will arrive, you could set the month pointer to December. And then you could set the dial to the day that you think winter starts on. And then you would turn the hand crank and move the moon phase dial until the pointer pointed to the new moon. And then you would read off the other dials to find out what the date would be in December when the new moon occurs. Or you could do the reverse, and if you knew when the next new moon would be, say, in the future, you could set your month pointer to whatever month you re-in, and then move the hand crank forward until you saw a new moon on the calendar dial, and then read off the date. It can also be used to predict eclipses. To do that, you would align the 2 dials on the front so that the numbers match up and then check the gearing between them. If the teeth of the 2 gears mesh evenly, then there will be no eclipse. If one gear has a tooth sticking out past the other, then you'll see either a partial solar or lunar eclipse. If the teeth don't match up at all, then you'll see a total solar eclipse. And I guess if they don't line up in just the right way, you could see a total lunar eclipse too. And if you're wondering why this works, well, let me tell you about the Saros and the Exeligmos. There are 2 ways to measure the length of a year. The tropical year measures the time between one spring equinox and the next. And the sidereal year measures the time between one night of the solstice and the next. One tropical year is 365.2422 days long. So we have to subtract 1/60th of a day from a sidereal year to get a tropical year. And one sidereal year is 360 degrees of the zodiac divided by 360 degrees of the ecliptic, which is 1 degree of the zodiac per day, which means that there's an extra 4 of those 60 ths of a day that we need to subtract off in order to get from the solstice to the next solstice. And that extra 4/60ths of a day is called the Saros. So when we rotate the back dial to keep the moon aligned with the stars, we're adding a fourth of a day to it every year. And every 60th year, the Saros adds up to a full day. So the zodiac aligns again, and the month dial needs to skip over a whole month to line back up. And this skipping over of the month is called the exoligmos. And the reason we have to do this is because the Earth's orbit isn't perfectly circular. So the Earth travels faster when it's closer to the Sun and slower when it's farther away. So the speed of the Sun relative to the stars depends on where the Earth is in its orbit. So far, I've only told you half of the story though, because there is a second smaller gear in here somewhere, and it skips over the month every 7 years. So we have to take the exoligmos into account too. And in fact, every 7 years the entire mechanism needs to be recalibrated. And it turns out that the Antikythera Mechanism could even tell you how long it would be before a particular eclipse happened. You see, the mechanism has 2 sets of pointers. There's the main pointer, and then there's this little one next to it. And what the little one does is it skips ahead a month every single year, and then every 7 years it skips ahead an entire exoligmos. So it jumps ahead 1/60th of a year, which is a whole month. So if you wanted to know how many days until a particular eclipse, you could use this small pointer to figure it out. And it turns out that it could calculate all of this and tell you what day the eclipse would happen on. Now astronomers figured all of this out from studying the Antikythera Mechanism, but archaeologists have a harder time figuring things out because it's missing some parts. We don't know what the pointer was pointing to on the back of the device, and we don't know what the other dial was tracking. We also don't know exactly what the instructions were on how to operate the device. It was clearly not intuitive because whoever owned this thing had to have written down the instructions and put them on a scroll and then lost the scroll, or maybe somebody lost the scroll in the shipwreck. Unfortunately, scientists don't agree on what the last dial might have been tracking. Some say it tracked the Pleiades star cluster, which would have helped farmers predict seasonal changes and planting times. But others say that it must have tracked Venus because they thought Venus was a god. And they wrote a book saying that it absolutely had to have tracked Venus. And you know what? They were probably right. I mean, why wouldn't Venus be important? I mean, my goodness, we named a planet after her. Okay. So what's missing from all of this is that we haven't told you how it works. You know, the actual mechanics of the thing. How did this crazy gear system manage to track all this stuff? Well, it's actually pretty simple. In terms of engineering, the number of atoms in the observable universe is approximately 10 to the 80th power. And the number of ways to arrange those atoms is also 10 to the number of arrangements. Power divided by the number of ways to arrange the atoms in the observable universe is 1 minus the number of ways to arrange the atoms in the observable universe. So it's essentially 0. Thus, there is only one way to arrange the atoms in the observable universe such that we end up with a human on the planet Earth asking questions about his place in the cosmos. This is the Antikythera Mechanism. It's an ancient Greek device which has left modern scientists baffled because of its complexity. But who actually built it? Hi, it's me and welcome to my channel. And let's ask the obvious question first. Who were the ancient Greeks? Well, they were a civilization in the Mediterranean about 2,000 years ago. They created amazing buildings like the Parthenon, incredible works of art and sculpture, and some very smart inventions like the water clock, the astrolabe, the odometer, and the crane. So clearly they were intelligent people. But that's pretty obvious when you look at these relics of their culture. What's less obvious are the things that they invented, but we don't still have any examples of. Things like this mysterious device found in a shipwreck off the coast of the Greek island of Antikythera, hence the name Antikythera Mechanism. The device was discovered in 1902 and has since been studied extensively. It was found in a pretty good state of preservation considering it's more than 2,000 years old. And it's a beautiful piece of engineering. We think that it's an analog computer from around 200 BC used to calculate astronomical positions and eclipses. How do we know that? Well, It has a series of rotating dials and pointers that indicate different aspects of the calendar, including the phases of the moon and positions of the planets. So how does it work? Well, there's no real way to tell because scientists haven't managed to fully decipher the instructions that it reads out. But what we do know is that it has a complex series of gears made from bronze inside the housing, which is made from either wood or ivory. There's also a handle on the side which would be rotated to wind up the device and get it going. Gears aren't easy to make. You need a lathe to turn metal into thin slices and then file those slices down to form a gear with many, many teeth. Even if you didn't have any machines, you could probably manage it if you had a lot of time. But not only are the gears very well made, there are a lot of them, and they fit together very precisely. In fact, the Antikythera mechanism is the oldest known example of a gear system. The next oldest examples that I could find were from around 800 years later, and they were made by Arab engineers. So there are two main theories as to how this happened. Either this was a completely unique invention by someone or some people who lived 2,000 years ago, or it was based on some long-lost knowledge that somehow resurfaced. And let me just say that it's really hard to imagine how somebody would come up with such a clever design without having some kind of head start. I mean, I can barely imagine how anybody would come up with the idea of making a YouTube video without having watched another YouTube video first. And speaking of clever people, one of the legends says that this was invented by Archimedes. He was a Greek mathematician, inventor, and engineer. He's credited with inventing everything from the crane to the compound pulley to the odometer, the Archimedes spiral, and even the machine gun. And he's said to have designed the gearing system for this device. There's no actual evidence to support this claim, though. It's just something that's written down in a book called Pneumatics by Hero of Alexandria. This was written about 1,000 years after the Antikythera mechanism was allegedly made. So it's basically hearsay. But let's assume that Archimedes did invent this thing. Where did he learn the technology from? Well, we know that he loved reading and studying the works of other scientists. So he probably learned the basics from books, and then he applied his own genius to improve the design. That brings us back to square one. Where did the books come from? Did Archimedes invent the wheel and just forget to write it down somewhere? Or was he taught the technology by somebody else? Well, there are mentions of similar devices in some ancient texts, like this one called the Celestial Clock by a writer named Pausanias, which describes a device capable of showing the positions of the sun, moon, and 5 planets. Another interesting detail is that there are marks on the dial that are only visible under ultraviolet light. These may have indicated where certain parts needed to be aligned so that the gears would mesh correctly. Something like that doesn't sound too difficult. If you have the right tools, you could replicate it today. But at the same time, it seems like this would have required some advanced knowledge of astronomy, mathematics, and physics, plus a lot of trial and error. So maybe it was just a fluke. Maybe a small group of scientists got together, shared their ideas, and came up with this design in a flash of inspiration. In that case, it wouldn't be something that would have been widely known outside of the group. So the Antikythera mechanism might have been the only example of its kind ever built. But here's the thing, gears are useful. Like once you know how to make them, you can make all sorts of cool stuff, like the Roman egg beater that I talked about in a previous video. So if the ancient Greeks knew how to make gears, why didn't they use the technology more often? Why didn't they build more sophisticated devices? I mean, we know that the Romans used gears because they left us lots of examples of figurines with moving parts. But other than that, we haven't found any other artifacts with gears until we find the Antikythera mechanism. So maybe they did have some other sophisticated machines, but they broke down or were disassembled for parts. But then why did the knowledge disappear after its creation? Well, there's a few possibilities. Maybe it was never widespread in the first place. Maybe only a few people knew how to build an Antikythera mechanism, and then they died and nobody knew what happened to them. Maybe it was deliberately kept secret to prevent the technology from falling into the wrong hands. Or maybe it was lost when Alexandria burned down in a civil war. A lot of important scientific texts were lost in that fire. There's also the possibility that the knowledge was deliberately suppressed by the ruling class. After all, most people would be better off if they didn't know how to make a sophisticated machine like this. And the ruling class didn't want to upset the balance of power. For example, if you had something like the world's first robot at a time when everybody else was working manually, that could cause a lot of problems. It would destabilize society. Another theory is that the destruction of the Library of Alexandria was a myth. The story goes that Julius Caesar accidentally set fire to part of the library while attacking the city, but in reality, it burned down during a civil war between Octavian and Mark Antony. Or maybe it was both. I don't know. But the point is that there isn't much archaeological evidence to back up this story. So maybe the Library of Alexandria wasn't this grand collection of all the world's knowledge, or at least not as big as we're told. Maybe it was just a local repository of scrolls and books that held little of value compared to other libraries across Greece. So while some knowledge may have been lost, it may not have been quite as catastrophic as is commonly believed. Whatever the truth is, we can't know for sure now because there's no evidence left behind. But this is my channel, and it's my job to come up with crazy ideas that might explain things. So here's my theory. What if the Antikythera Mechanism was built by a school of ancient scientists? They would meet up regularly and share their ideas and discoveries. It was kind of like a club or a guild. And the reason why we haven't found any evidence of it is because they operated in secret. They had initiation rituals and passwords, and none of the outsiders knew what was going on. Think about it. If you were part of this secret organization, you might have been proud to put a special symbol on your house, or maybe you wore a ring or a pendant with a particular shape that showed others that you belonged. But those symbols are long gone, if they ever existed. What we consider to be the peak of Greek culture, with all of the statues and temples and plays, was really only the tip of the iceberg. Under the surface, there was a lot of secret activity. Secret societies and cults were incredibly popular in ancient Greece. I mean, even Plato's Academy was basically a cult, if you think about it. So yeah, that's my theory. Ancient Greek science was actually much more advanced than we give it credit for. There was a hidden curriculum of practical knowledge that was passed around secretly, and we've only caught glimpses of it in artifacts like the Antikythera Mechanism. Now, if you'll excuse me, I have to go and join my secret society for a meeting. Yes, I know that I'm not a real Greek, but the Greeks had a word for that. They called it a philosopher. The discovery of the Antikythera Mechanism, an ancient Greek or possibly even earlier device from the island of Antikythera, has shocked the archaeological world. It has been referred to as the world's first computer by some, and has led many to wonder if there are other examples of ancient technology like this just waiting to be found. And there is evidence that there may very well be. There are two things worth noting right away about the Antikythera Mechanism. First, we haven't found anything else like it yet. Second, there are mentions in ancient literature of similar devices. So why aren't there any other examples? Did the Antikythera Mechanism really exist in numbers far exceeding what we've found? Or were these ancient accounts simply referring to some other type of instrument entirely? Let's take a look at what we know so far. The artifact itself is remarkable. Discovered in 1902 in the Antikythera shipwreck, it dates back to somewhere between 200 BC and 70 BC. Though recent research suggests it may have been created as late as the 1st century AD. It consists of several bronze gears enclosed in a wooden box with a series of dials and pointers on the front used to tell the time, display the phases of the moon, track the position of the sun, predict eclipses, and even show the dates of the Olympic Games. There's still a lot that scientists don't understand about it, but its complexity and sophistication have made it one of the most important archaeological finds ever. The discovery was made by a team of fishermen who stumbled across the shipwreck while searching for sponges. As they dove into the depths to collect the sponges, they noticed the remains of an ancient vessel filled with pottery. What they didn't realize at the time was that the pottery contained much more than just old dishes and jars. Amongst the debris, there was also a small bronze lump, which turned out to be part of the gear train of the mechanism. In total, only 2 fragments of the original device remain today. One is held in the National Archaeological Museum in Athens, Greece, while the other resides at the University of Athens. The fragment in Athens is the larger of the two and contains the main gear train. Scientists have been able to reconstruct some of the device's features, including its calendar function and its ability to calculate the phases of the moon. They've also determined that it was powered by a crank on the side, which would have been rotated by hand to wind up the mechanism. This is evident from the hole where the handle once attached, and the grooves left in the gears from where the handle would have turned. But there's another piece to this puzzle. A small bronze plate found amongst the wreckage appears to be a pointer or dial. Its exact purpose is unknown, but it's believed to have been attached to the missing portion of the mechanism. If so, it would have been mounted on the front of the device, allowing the user to read the various astronomical positions and calculations. What's interesting about the pointer is that it bears witness to the ingenuity of the creators of the Antikythera Mechanism. Inscribed upon it are the names of the months in alphabetical order, but not in Greek. Each month is written in the exact same way it was written in the English language. This is significant because there is no known connection between the Greeks and the English. The alphabet used here is called Hieratic Egyptian and was used by the ancient Egyptians around 3,000 years ago. It remained in use until the 4th century AD, when it was replaced by the Greek alphabet. But how did the Greeks come to use an Egyptian alphabet? Well, there is evidence that the Egyptians visited Greece sometime before the 4th century BC. But aside from a few isolated incidents, there was never any significant cultural exchange between them. For example, Herodotus wrote that the Egyptians had never even heard of the existence of the Scythians until the time of his writing around 440 BC. Likewise, he reported that the Greeks only learned of the Nile River through stories told by the Babylonians, which makes it unlikely that the Egyptians would have had any influence on the development of the Antikythera Mechanism. So either the ancient Egyptians traveled to Greece and invented the device, or they must have been visited by someone else. And this is where the story takes an unexpected turn. You see, over 2,000 years ago, the author Pausanias wrote of a curious observation during his travels. He came across an altar dedicated to a forgotten god named Theseus, whose likeness was stamped on coins bearing the inscription, Thundering Zeus. Puzzled by this unusual deity, Pausanias consulted an old man named Aristarchus, who informed him that Theseus was an Indian god who arrived in Greece around the 14th Olympiad. That was between 648 and 632 BC. This was long before Alexander the Great's conquest of India. According to Aristarchus, Theseus taught the Greeks many things, including astronomy, the art of war, and how to make all kinds of mechanical devices. He said that Crates built towers, constructed catapults, and even created devices that could speak and move on their own. Some people thought he was a magician. He showed the Greeks how to make natural dyes, how to preserve food for storage, and even how to cast metal in molds. But when Crtea died, his disciples forgot his teachings. Only a few scraps of his writings survived, and those were taken out of context and attributed to Pythagoras instead. Now, does this mean that Crtea was actually a visitor from India who brought with him knowledge of advanced technology? Not necessarily. While there is evidence to suggest that the Greeks did interact with Indians to some extent, most scholars believe that Crates was probably a real person who lived during the Archaic period, and that his ideas were inspired by his travels to India rather than being imported directly from there. Either way, the point here is that Crates was a contemporary of the ancient Greek astronomer and mathematician Thales of Miletus, who is considered to be the father of Greek science. We know that Thales studied astronomy, geometry, and the natural world, and that he developed a passion for understanding the fundamental principles that govern the universe. It was he who predicted the solar eclipse of 585 BC and correctly guessed the length of a year to within less than a day. We also know that Thales lived near the coast in the city of Miletus, which was a major trading hub, and thus likely had ties to the wider Mediterranean world. These factors alone make it plausible that Thales would have met Crates and learned some of his mechanical secrets. It is important to remember that the Antikythera Mechanism isn't the only example of advanced engineering from antiquity. In fact, there are dozens of artifacts that have been discovered throughout history that challenge our understanding of how advanced ancient civilizations really were. Take, for instance, the Baghdad Battery. This collection of clay, copper, and iron objects was excavated from a site near Baghdad in 1936. Though it is not exactly clear how old the battery is, most historians agree that it dates back to somewhere between 250 BC and 750 AD. Then there's the mystery of Yonaguni Monument, a large stone structure located off the coast of Yonaguni Island in Japan. Its origins are unknown, but some believe it could be the remnant of a lost civilization that thrived in the region thousands of years ago. Who knows what else might be buried beneath the waves, just waiting to be found. Perhaps the most compelling evidence that there could be more Antikythera mechanisms out there comes from the discovery of a similar device found in a Roman villa near Naples. Known as the Gyrian mechanism, it was crafted during the 1st century AD and is virtually identical in design to the Antikythera mechanism. This lends credence to the idea that such devices weren't unique or rare, but rather commonplace. In fact, There may have been many more examples scattered throughout the ancient world. So why haven't we found them yet? One possibility is that they were deliberately destroyed. After all, when the Roman Empire fell and Europe descended into chaos and warfare, it's likely that many people saw value in destroying anything that could be used as a weapon. Even during World War II, both sides took great pains to destroy factories, transportation systems, and even homes. It wouldn't be unreasonable to assume that someone with enough power and knowledge could have ordered the destruction of anything deemed too dangerous. Another explanation is that they were simply lost. The passage of time can have a devastating effect on our ability to understand history. Over the centuries, entire cities have been abandoned and reclaimed by nature, leaving behind only ruins and artifacts. Many ancient sites have been looted and pillaged, with countless treasures lost forever. It's entirely possible that the Antikythera Mechanism was once part of a larger group of artifacts, but that they were separated over time and are now scattered across the globe. Some people believe that they haven't been found because they never existed at all. This argument is based on the assumption that the Bible is literally true and that God destroyed all traces of ancient technology when he flooded the earth. This, however, is a fringe theory not supported by mainstream scholarship and lacks any real evidence. Whatever the truth may be, one thing is certain: the discovery of the Antikythera Mechanism has revolutionized our understanding of ancient Greek culture. It's a testament to their ingenuity and a reminder that there is still so much we don't know about the world around us. Perhaps one day we'll uncover more secrets from antiquity that will change history as we know it. Until then, the Antikythera Mechanism will continue to captivate scientists and historians alike. The shipwreck that hid the Antikythera Mechanism. This is the only thing that we know for sure about the shipwreck that was discovered with the Antikythera Mechanism on board. It was incredibly deep. The vessel was sitting at a mind-boggling depth of 70 feet below sea level. This makes it quite possibly one of the deepest wrecks ever found. In fact, even today, divers can only explore depths of around 130 feet in exceptional circumstances. Back when the Antikythera Mechanism was discovered, this would have been completely out of the question. People back then could only go as far down as 30 feet, usually no further. So the ship probably sat undiscovered for thousands of years because it was simply too deep for humans to reach. What else was found? Aside from the mysterious device, 2 other items were found inside the shipwreck. These included a few marble statues and an assortment of Greek coins. It's believed the coins may have come from the same time period as the actual mechanism, but it's not known if they were dropped by passengers thrown in by slaves or brought on board with the intention of trading them. Some historians also believe the presence of the marble statues suggests the ship once carried important cargo. Where did it come from? There are 3 different theories about where the ship came from. Some scholars think the ship had traveled from Greece to Egypt. Others believe it sailed between the Greek island of Rhodes and the city of Antioch in Syria. And the final theory is that it was traveling between Athens and the Egyptian port city of Alexandria. According to all 3 of these theories, the ship sank sometime during the 1st century BC, placing it at about 2,000 years old. What was it carrying? Unfortunately, there is no way to tell what else the ship may have been carrying. Most people assume it must have been filled to the brim with the Antikythera Mechanisms, but that's probably not true. Archaeologists believe the ship most likely wasn't designed to transport a single complicated device like the Antikythera Mechanism. Instead, it probably carried multiple small mechanisms. They may have been small parts to larger devices or completed mechanisms that were simpler than the one that was found intact. Researchers recently discovered a piece of clay that looks like it might have been used to mold gears. But unfortunately, without more evidence, there's nothing to say for sure. How did it stay hidden? It's easy to see how the wreck could have stayed hidden for so long. For one thing, it was incredibly deep and archaeologists didn't have the technology needed to reach it until very recently. But another reason is because the seabed shifted over time. This moved the wreck to a different location, making it even harder to find. The area where the shipwreck was ultimately discovered was just a happy accident. It happened when fishermen pulled up the marble statue from the seafloor, not realizing they had unearthed part of a historical treasure. Soon after, the rest of the shipwreck was discovered and the world was stunned. Why didn't they excavate it? You're probably wondering why archaeologists didn't dig up the entire site and excavate every last bit of debris. Well, there are a couple of reasons. First of all, doing so would have damaged the site. And since it's so deep, it would have been extremely hard to do without causing damage. Another reason is because the wreck is protected by law. Since the shipwreck was declared an ancient monument in 1902, it's illegal to touch anything inside it. There are also laws protecting underwater antiquities. So everything found inside the wreck must remain there unless permission is given by the Greek government. And to make things even more difficult, getting permission for such an undertaking would be almost impossible. If the Greek government did allow it, the excavation would require millions of dollars and the cooperation of several different entities. Divers would have to work under extremely dangerous conditions, risking their lives to unearth the artifacts. And even if they managed to bring some to the surface, the artifacts could easily be damaged due to the immense pressure and lack of oxygen at such great depths. The risks involved in underwater archaeology. To understand how difficult it is to excavate a shipwreck, let's look at the dangers faced by archaeologists working in the depths of the ocean. The biggest threat to any diver is getting the bends. This happens when someone rises too quickly to the surface, allowing nitrogen to form bubbles in their bloodstream. And in severe cases, it can be deadly. That's why divers must slowly ascend to the surface to avoid this potentially fatal situation. But the problem with this is that it takes hours to do. And that's assuming the diver is alone and has no heavy equipment with them. Archaeologists working on the Antikythera shipwreck wouldn't just have to worry about themselves, but also about the valuable artifacts they'd be carrying back to the surface. Every object they recovered would weigh them down and make the ascent much more difficult. If they started to sink, they would have to release the objects and risk losing them forever. In many cases, underwater archaeologists will anchor themselves to the seafloor while they work. That way they don't have to worry about ascending to the surface with heavy loads. But this means they can't explore large areas. They are essentially tethered to one spot and unable to move. Another danger is getting lost. When divers descend into the water, they are met with an underwater world unlike any other place on Earth. It's dark, silent, and full of unseen dangers. Even the most experienced divers can become disoriented underwater, especially if they're exploring a shipwreck. With all the broken pieces of wood and debris lying around, it's easy to lose track of where you are. And finally, there's the cold. When divers descend into the water, the temperature around them drops dramatically. This can cause their body temperature to drop as well, leading to hypothermia. To prevent this, divers wear special suits that keep them warm. But even with these precautions, it's only a matter of time before hypothermia kicks in. For this reason, most dives last no longer than an hour. The future of the wreck. At this point, it's unlikely that the wreck will ever be fully excavated. There have been some suggestions that it should be left alone and preserved in its current state. This is probably the best option, considering the risks involved in trying to recover more artifacts. However, new technologies may change everything. One day it may be possible to map the wreck in 3D and create virtual models of it. This would allow us to explore the wreck without ever having to get wet. Maybe one day we'll even be able to send robots down to recover artifacts from the wreck. Until then, we can be thankful that we have the few pieces that we do. What do you think? Do you think the wreck should be left alone, or do you think we should try to excavate it? Let me know in the comments below. What if someone came along and handed you a piece of technology that was hundreds, even thousands of years ahead of its time? Well, that's exactly what happened to scientists when they discovered a strange object in a shipwreck off the coast of Greece. The strange thing was a highly advanced piece of technology that defied all expectations. It forced experts to completely rethink everything they thought they knew about history, and they're still struggling to come to terms with it. This is the mysterious Antikythera Mechanism, and it may rewrite history. The discovery of the Antikythera Mechanism began like many great discoveries due by accident. In 1902, a group of sponge divers were working off the coast of the Greek island of Antikythera when they came across an ancient Roman shipwreck. Excited by their find, they began to salvage the vessel, hoping to find valuable treasures that could be sold. But they had no idea that they were about to stumble upon something truly special. As the divers searched through the wreckage, they uncovered a large number of clay jars that had been used for storing wine. But one jar stood out from the rest. Inside was a small, oddly shaped piece of metal that didn't look like anything the divers had seen before. It was rough and unpolished, covered in corrosion, so they had no idea how old it really was or what it was used for. But when they brought the strange object back to shore, experts realized that they had stumbled upon something incredible. The object turned out to be a complex piece of machinery made of bronze. It was covered in gears, dials, and markings that suggested it was some kind of astronomical calculator. It was later named the Antikythera Mechanism after the Greek island where it was found, and it became clear that the artifact was far more advanced than anyone had expected. To make matters even stranger, experts were unable to date the device accurately. At first, it was believed to be around 2,000 years old, but further analysis revealed that it was actually much older, possibly dating back to the 2nd century BC. This posed a serious problem because at the time there was no scientific evidence that ancient humans were capable of creating such a sophisticated piece of technology. Even more shocking was the fact that the Antikythera Mechanism appeared to be a highly advanced piece of engineering. It had moving parts and was incredibly precise, able to calculate the phases of the moon and the positions of the planets with remarkable accuracy. The device also had a number of other features that made it truly unique. For example, it had a calendar function that allowed users to keep track of the days of the year. It also had a sound-making device that produced a chime every hour. Scientists have been baffled by the Antikythera Mechanism ever since it was discovered. They've spent decades trying to understand how it works and who created it. What they've learned is that the device is incredibly complex and was likely created by someone with a deep understanding of mathematics and astronomy. It is so advanced that many experts believe it must have been created by someone with access to technology far beyond what was available at the time. In fact, the complexity of the Antikythera Mechanism has led some experts to believe that it wasn't created by ancient humans at all, but by an ancient civilization that we're not aware of. One of the most intriguing aspects of the Antikythera Mechanism is the fact that it appears to have been created using techniques that were lost over time. The gears and other components are so finely crafted that they would have required tools and materials that are no longer available. This suggests that there was a period of time in history when humans had access to advanced technology that they eventually lost. It is possible that the Antikythera Mechanism is simply a reminder of a time when humans were more advanced than they are today. If this is true, then it suggests that there is much more to the story of human history than we are aware of. There may be entire civilizations and periods of time that have been lost to history, leaving us with little more than fragments of what once was. If this is true, then the Antikythera Mechanism is just the tip of the iceberg. There could be other artifacts out there that are just waiting to be discovered. When you think about the fact that the Antikythera Mechanism was created over 2,000 years ago, and yet it was still so advanced, it's hard not to wonder what else might be out there. Perhaps there are other pieces of technology that were lost to time that could revolutionize our understanding of history. The Antikythera Mechanism has been the subject of numerous theories over the years. Some experts believe that it was created by a lost civilization that was more advanced than any other in its time. Others believe that it was created by an alien race that visited Earth in the distant past. However, these theories are largely considered to be fringe, and there is little evidence to support them. Most experts agree that the Antikythera Mechanism was created by a human civilization, but they can't agree on which one. Some believe that it was created by the Greeks, while others believe that it was created by the Egyptians or the Babylonians. Unfortunately, there is no way to know for sure who created the Antikythera Mechanism, but scientists continue to debate the issue. One of the main reasons why scientists are so interested in the Antikythera Mechanism is that it could rewrite history. If it turns out that the mechanism was created by a lost civilization, then it could force experts to completely rethink what they know about human history. It could also shed light on the origins of science and technology and help us better understand the development of our world. However, the Antikythera Mechanism has also been the subject of much controversy. Some experts have argued that it doesn't deserve the attention it has received and that it is not as important as some people believe. They argue that it is nothing more than a curious artifact that should be studied in its own right, and that it doesn't have any broader implications for history. Despite the controversy, the Antikythera Mechanism continues to fascinate experts and the general public alike. It is one of the most mysterious and enigmatic artifacts ever discovered, and it has captured the imagination of people all over the world. People have been captivated by the mystery of the Antikythera Mechanism for decades, and it continues to be one of the most popular topics in archaeology and history. Over the years, There have been numerous theories about how the mechanism works and who created it. Some of the theories are more plausible than others, but all of them are fascinating in their own way. The mechanism has been the subject of books, documentaries, and even movies, and it continues to be a popular topic in the media. Today, the Antikythera Mechanism is on display in a museum. It's one of the most prized possessions of the museum and is the centerpiece of its collection. The mechanism is kept in a climate-controlled room and is only displayed for a few hours each day. This is to protect the artifact from damage and to ensure that it's preserved for future generations. So what does the discovery of the Antikythera Mechanism tell us about the history of science? Well, for starters, it shows that ancient humans were much more advanced than we previously thought. The device is so complex that it would have required a deep understanding of mathematics and astronomy to create. It also suggests that there was a period of time in history when humans had access to advanced technology that they eventually lost. Finally, it shows that the history of science is much longer and more complex than we previously thought. The Antikythera Mechanism was created over 2,000 years ago, and yet it was still so advanced. It helps us better understand the development of our world. Now, you might be wondering why it took so long for scientists to realize the significance of the Antikythera Mechanism. After all, it's such an important piece of history that it should have been obvious how significant it was. However, when the mechanism was first discovered, it was just one of many artifacts found in the shipwreck. As a result, it wasn't given much attention, and it wasn't until much later that scientists realized its true importance. Overall, the discovery of the Antikythera Mechanism is one of the most important archaeological finds of the 20th century. It has forced experts to completely rethink what they know about ancient humans and has shed new light on the history of science and technology. As we continue to learn more about the mechanism, we can expect even more revelations about the past. Who knows what other secrets it's hiding? The Antikythera Mechanism remains one of the most tantalizing mysteries in history. It's a reminder of a time when humans were more advanced than we realize and a testament to the ingenuity of those who created it. As we continue to explore the ancient world, we can be sure that there are many more secrets waiting to be uncovered. Almost a century later, we're still struggling to unlock its secrets, but some clever engineers have come tantalizingly close to building their own replicas. So today, let's find out just how they did it. In this photo, we see the first attempt at recreating the Antikythera Mechanism. It was made by a team led by the engineer Archimedes in 1974. They recreated the outer bronze casing and included the dial that would have allowed the user to read off the various astronomical positions displayed on the main plate. However, it didn't include the actual gearing or the internal mechanisms that drove the entire thing. And even though the actual Antikythera Mechanism is mostly missing, this recreation was only about 60% complete. Still, it was a good start and a testament to the fact that such a complex device could actually be built by hand without the use of computers or CNC machines. Unfortunately, as time went on, the project was abandoned. This may have been because funding dried up, or it may have been due to the sheer difficulty involved. After all, the original device was discovered in pieces, and what remained was mostly a corroded mess of bronze and dirt. For a long time, we didn't even know how many pieces were originally there. Fast forward to modern day, and we now have high-resolution scans of every remaining piece and computer models that show us exactly how it fits together. Now, not only did these scans allow us to virtually rotate the device and marvel at its intricate details, but they also gave us a clear picture of what was missing. We can see exactly where parts have broken off, and in some cases we can even make out the thread where screws once held things together. Now, while this was great news, it came with a bit of a caveat. We didn't really know what to do with this information. Sure, a handful of people had attempted to create their own replicas, but they all more or less followed the same technique that had been used in 1974. That is, try to recreate the outer case and any external features, then somehow reverse engineer the internal mechanisms. The problem is that this can lead to some pretty inaccurate recreations. Take this example. The gear in question should have 28 teeth, but this one only has 24. Small differences like this can throw off the entire device, making it inaccurate or even preventing it from working altogether. The breakthrough finally came when a group of engineers used 3D modeling software to painstakingly model each gear tooth, attempting to match each one to its corresponding mating gear. This was tedious work but it allowed them to ensure that every gear tooth was accounted for and that the overall design was as accurate as possible. Using this method, they were able to get their replica to the point where it showed the correct positions for the Sun, Moon, and 5 planets known in Ptolemy's time. Not bad, right? Well, unfortunately, there were still some issues. The biggest being that it couldn't keep accurate time. You see, the way the original device kept time was through a series of pinwheels. These pinwheels would have been attached to a motor that wound up and released the tension on these pins, allowing them to fall down into a recess and reset the various gears. Unfortunately, the replica didn't include this system and instead relied on a regular crank to rotate the gears. As you can imagine, this made it incredibly difficult to keep accurate time since you need to wind up the motor and reset the pins by hand every 24 hours. Okay, so a 3D model that accurately represents the overall form of the device, but doesn't actually work. Where does that leave us today? Well, believe it or not, we've actually come quite a bit further. Today there are 3 separate teams who are each trying to build their own full-size, fully functional replica. One team located in Greece has been working on their replica for over 20 years, and they claim to have built the most accurate replica to date. According to the team, their device is able to accurately display the positions of the Sun and Moon and even keeps accurate time down to the second. They say that it's missing some of the more decorative elements, such as the pointers that would have been used to read off the calendar dates. However, it can calculate the dates as well as the positions of the 5 classical planets. Pretty impressive. However, there is another team that claims to have beaten them. In fact, they claim that they've not only built a replica, but that they've improved upon the original design. Okay, I can hear you asking, how could they possibly improve on a device that's 2,000 years old? Well, it turns out that they've done exactly that. See, while the Antikythera Mechanism was an amazing feat of engineering, it wasn't perfect. It lacked the ability to calculate eclipses, which was likely an oversight rather than a flaw. Eclipses are relatively rare events, so they probably weren't worth the extra effort. However, this team saw an opportunity to make a name for themselves, and so they set about creating a new device that could do what the Antikythera couldn't: predict eclipses. They accomplished this by adding additional gears to their replica, a move that brought their total number of gears up to 257. This addition allowed their device to not only track the positions of the planets and the lunar cycle, but also calculate solar and lunar eclipses. But wait, there's still another team working on their own replica. And while they may not have eclipse prediction capabilities, they do have something that the other 2 lack: transparency. That's because their device is made from clear acrylic instead of solid metal. This makes it much easier to see exactly how everything is put together, which is why I think their device is the best candidate for winning our hypothetical machine contest. But what if we take a step back and consider the broader implications of these incredible machines? What have we learned from the various attempts to reconstruct it? For starters, we've learned that it wasn't a one-person job. It took a team of highly skilled craftsmen to produce such an intricate device. We also learned that it took a very long time. No way a single person could have produced all of the gears in the time that it was being used. That means that whoever was in charge of producing these devices oversaw the creation of multiple ones over the course of several decades. We've also learned that it required specialized tools that were likely produced outside of Athens. You see, the Antikythera Mechanism was likely produced around Athens since that's where the vast majority of them have been found. However, the gears and pinions that drive the device are far too small to be produced using the types of lathes available at the time. To create the smallest pinion, you need a lathe that could cut gears with an accuracy of plus or minus half a degree. Unfortunately, such precision simply wasn't possible until nearly 2,000 years later. The only plausible solution is that these pinions were produced elsewhere and imported into Athens, where they were then assembled into the finished device. Finally, we've learned that it was more complicated than we originally thought. Back in 1974, it was believed that the Antikythera Mechanism contained about 30 gears. However, recent analysis has revealed that it likely had closer to 40. This is a big deal because it means that the device was more complicated than we realized, which makes it all the more remarkable that such a device could have been built without the aid of modern tools. So the question becomes, are we close to fully unlocking its secrets? In a word, yes. With the help of computer modeling and modern manufacturing techniques, we've been able to create remarkably accurate replicas of the Antikythera Mechanism. The fact that we've been able to do this with such limited evidence is a testament to the ingenuity of the people who lived 2,000 years ago. But it's also a reminder that we still have a lot to learn. There are still many things about the Antikythera mechanism that we do and understand, and it will likely be a long time before we do. But with each passing year, we come a little closer to understanding one of the greatest mysteries of the ancient world. What do we really know about the Antikythera mechanism? In this episode, we're going to explore some alternative theories that have been put forward about one of history's most important archaeological finds. We often think of ancient Greek civilization as a sort of origin point for Western civilization, a society where arts and sciences flourished and whose innovations sparked the scientific revolution that would change the world. So when we find artifacts of ancient Greek civilization, they're often considered all the more remarkable for being the earliest examples of their kind. That is, after all, what made the Antikythera mechanism so remarkable in the first place, right? Well, maybe not. The device was found broken into several fragments, but archaeologists were able to reconstruct it well enough to see that it was an incredibly advanced piece of technology, especially for its age. It was clearly some kind of analog computer used for astronomical calculations and sophisticated gearwork, something not seen again until about 1,500 years later with the invention of the Maybach in Europe. But many of the details of the artifact are still a mystery. We don't even know exactly what it was used for. We can tell that it had something to do with tracking the cycles of the moon and the planets, but the exact nature of its capabilities are still debated among experts. And while it's commonly referred to as the ancient Greek supercomputer, historians now believe that the creators of this device may not have been Greek at all. There are plenty of reasons to think that the device may have been created elsewhere and then lost to history. But are there any real candidates for who might have created this device if it wasn't the Greeks? One possibility is that the Antikythera mechanism may have been inspired by, or even created by visiting scholars from Egypt. While there isn't much evidence of trade between the two regions during this time period, it's possible that scholars could have traveled independently, as there were well-established cultural and intellectual exchanges throughout the Mediterranean. This theory is bolstered by the fact that the Egyptian calendar and astronomical observations were extremely detailed and accurate, dating back thousands of years before the Greeks began keeping records. There is also some circumstantial evidence that scholars from Alexandria in particular would have had both the means and the motivation to create such a device. For example, in the 2nd century BC, Posidonius, a Greek philosopher from Athens, traveled to Alexandria to study under the astronomer Aristarchus, who had developed a heliocentric model of the solar system, putting the sun rather than the earth at the center. But most importantly, Posidonius was friends with another man named Crates, who was famous for his knowledge of machines and engineering. Crates built all kinds of amazing devices, including a water clock, a machine that could play music, and even a puppet theater. And he spent much of his life traveling around the Mediterranean showing them off. So it's plausible that he could have been the one to create the Antikythera mechanism and then show it to Posidonius, who then took the idea back to Athens, where it would have been lost to history after the city was sacked by the Romans in 86 BC. But there is another theory that's even older, one that posits that the Antikythera mechanism wasn't just created in Egypt, but by the legendary Babylonians, who, according to some accounts, invented the wheel and numbers and everything else. Okay, not everything, but certainly lots of stuff. Now, if you've watched our series on Babylon, you'll know that they were one of the great civilizations of the ancient world, whose empire stretched from modern Turkey all the way to the Persian Gulf. They pioneered everything from metalworking to law codes, and even the first known schools. But if they were so advanced, why haven't we heard of them before? Well, because like the mythical Atlantis, they met a gruesome end. According to Plutarch, a Greek historian writing in the 1st century AD, the Babylonians were wiped out by a catastrophic flood, which destroyed their great works and sent their surviving scholars running to Greece. Others argue that the Babylonians were instead conquered by the Assyrians, who may have deliberately destroyed their cities. Either way, they seem to have vanished overnight, taking their secrets with them. And it turns out that they, too, may have had a highly advanced understanding of the universe. See, while the Greeks were busy building democracy, the Babylonians were making some pretty incredible astronomical discoveries. They kept meticulous records of the planets and stars, and eventually even mapped the zodiac. But some scholars believe that they may have taken their studies even further and constructed their own supercomputer to track the movements of the heavens. The leading proponent of this theory is the British historian and archaeologist Alexander Thom, who argued that the Babylonians didn't just have a deep understanding of the cosmos, but that they actually measured it. He pointed to various pieces of ancient Babylonian art that appear to depict astronomical instruments, including a 2,000-year-old cylinder seal that seems to show a device remarkably similar to the Antikythera Mechanism. Of course, this is only one piece of evidence, and it's admittedly quite a stretch to go from a seal depicting a hypothetical instrument to claiming that it was actually used by real astronomers. But Thompson saw other parallels between Babylonian culture and the Antikythera Mechanism. He noted that the device seemed to have been created at a time when Greek culture was relatively undeveloped and that it used a completely different numbering system than the Greeks, one that was based on 60 rather than 10. These details, plus the fact that it was discovered on an island that was once part of the Babylonian Empire, convinced him that the device must have originated in Mesopotamia. Now, it should be said that not everyone agrees with Thompson's interpretation of the evidence. Many scholars point out that there is no hard proof that the Babylonians were familiar with gears and bronze casting, which suggests that they wouldn't have had the technology to build such a sophisticated device. But while those claims have merit, they don't tell the whole story. You see, there is a growing body of evidence that suggests that the Babylonians weren't just living in the shadow of the Assyrians. They were actually their masters. For decades, historians believe that the Assyrians had brought an end to the Babylonian Empire in 609 BC and replaced them with their own. But recent excavations at the site of the ancient city of Nineveh have revealed that the Babylonians had already destroyed the Assyrians 3 centuries earlier, in 626 BC, ending their reign and allowing the Babylonians to take control of the region. This would have been a golden age for the Babylonians, lasting for over a century, during which they would have had ample opportunity to make scientific discoveries and develop new technologies. And with that development came the potential for greatness. Some scholars believe that if given the chance, they may have rivaled the Greeks and become the dominant power in the region. But their moment in the sun was short-lived. In 539 BC, the Persians swept through the Middle East, conquering the Babylonian Empire and destroying its capital city, bringing an end to its way of life. Once again, this allowed Greek culture to flourish, and historians believe that some Babylonian scholars fled to Greece, bringing their knowledge with them. There's also evidence that the Antikythera Mechanism may have been influenced by other cultures as well. When the device was first discovered, the prevailing theory was that it was completely unique, the product of an entirely original invention. However, in the late 20th century, scholars realized that it may have been part of a larger tradition of sophisticated astronomical instruments. Archaeologists uncovered the remains of other devices in Greece and Italy that appear to have been related to the Antikythera Mechanism, suggesting that its creators may have been part of a wider community of scientists and engineers. Perhaps the most intriguing is a fragment of a bronze gear found near Athens that dates back to the same time period. It's much simpler than the Antikythera Mechanism, but may have served as its inspiration. So what did the creators of the Antikythera Mechanism actually look like? Well, unfortunately, nobody knows. But if you'd like to find out what they wore, you're in luck. That's because a team of textile scientists recently recreated the clothing of the ancient Greeks using historical records and archaeological finds. The result is a collection of beautiful garments that bring ancient Greek fashion to life. The Antikythera Mechanism is an ancient Greek device from around 200 BC. It's the world's first known analog computer. It can calculate astronomical positions and eclipses, but when we look at its design, it bears an uncanny resemblance to some ancient Chinese or Indian inventions thousands of years later. So how did the ancient Greeks manage to invent such a sophisticated device? And more importantly, could there have been a civilization even older than Greece that invented something similar? Well, it's true that many scientists believe that the Antikythera Mechanism was ahead of its time. They believe that the complexity of the device indicates that it was crafted at least 1,000 years before it was actually found. And what's really interesting about this artifact is that it wasn't discovered in Greece at all, but instead near the Greek island of Antikythera, which is where it got its name. It was found in a Roman shipwreck that was probably carrying it from somewhere in the east to Greece. But before we start thinking that perhaps the ancient Chinese invented the Antikythera mechanism and then passed it off to the Greeks, we should point out that this theory is based entirely on the similarities between the device and some ancient Chinese inventions. In reality, the evidence for who created the Antikythera mechanism is very weak. It may have been made by the Greeks, the Chinese, or someone else entirely. And the fact that the Romans were transporting it does tell us one thing. At this time, the Romans were not known for their mechanical inventions. Instead, they were known for their military strength and their impressive engineering projects like aqueducts and roads. So if the Antikythera mechanism was indeed a Roman invention, then it would have been very rare for them to create such a complex piece of technology. The fact that they were transporting it suggests that they didn't make it themselves, but rather obtained it from another civilization. So could it have come from India or China? Well, it is true that there are some striking similarities between the Antikythera mechanism and some ancient Chinese and Indian inventions. The most obvious similarity is with the Chinese armillary sphere, which is a model of the cosmos that was used to predict astronomical positions. Like the Antikythera mechanism, the armillary sphere consists of a series of interconnected gears and shafts that can be used to track the movement of celestial bodies. There are also some similarities between the Antikythera mechanism and some ancient Indian inventions. For example, the Indian astronomer and mathematician Brahmagupta described a device called a chakravala, which is a type of astrolabe used for astronomical calculations. The chakravala is very similar to the Antikythera mechanism in terms of its function and its appearance. Now, these similarities have led some people to believe that there was cross-cultural technological exchange between India, China, and Greece. However, it's important to note that these similarities are only skin-deep. The Antikythera mechanism is a far more advanced device than anything else known from ancient China or India. It is possible that the ancient Chinese or Indians may have had some mechanical knowledge that the Greeks didn't have access to. But considering the vast differences between the civilizations, it's unlikely that they would have had the same level of technological advancement. So even though the Antikythera mechanism may bear a striking resemblance to some Chinese or Indian inventions, it's probably just a coincidence. If there was any cross-cultural exchange of technology, it was probably the other way around. The Greeks may have had contact with the Chinese or Indians through trade routes like the Silk Road. Through this trade, the Greeks would have had access to some of the technologies and innovations of the East, including things like paper, gunpowder, and the compass. These innovations would have been very useful for the Greeks as they began to explore the world and set up colonies in new territories. It's also possible that the Antikythera mechanism was brought to Greece by a traveler like Pausanias, who was a Greek astronomer and mathematician who lived in Alexandria. He traveled to India and China and brought back astronomical tables and instruments that he had seen there. But the truth is, we don't know exactly how the Antikythera mechanism got to Greece. We do know that the Romans were transporting it in a shipwreck, but they likely didn't make it themselves. So it could have come from India, China, or anywhere else. If we want to find out where it really came from, we need to look elsewhere. One possibility is that a similar device could have existed in Mesopotamia. The Babylonians were known for their astronomical observations and their ability to predict eclipses. They had a number of different tools that they used for astronomical calculations, including a device called a water clock. Water clocks were used all over the ancient world for telling time, but the Babylonian water clock was much more advanced than anything else known from the time period. It was able to keep accurate time even when the temperature changed. This suggests that the Babylonians had a sophisticated understanding of hydraulics and mechanics. They may have used this knowledge to develop other mechanical devices, including a device similar to the Antikythera mechanism. Unfortunately, there's no direct evidence that the Babylonians ever created a device like the Antikythera mechanism. However, it's possible that such a device could have been lost to history. The Babylonians kept their astronomical records on clay tablets, which are much less durable than metal or stone. Many of these tablets have been eroded or destroyed, which means that there's a good chance that some of their scientific discoveries have been lost forever. Another possibility is that the Antikythera mechanism was inspired by the work of the Hellenistic scientists and engineers. The Hellenistic period was a time of great cultural and intellectual exchange in the ancient world. It lasted from the death of Alexander the Great in 323 BC until the conquest of Egypt by Rome in 30 BC. During this time, there was a lot of contact between the Greeks, the Egyptians, and the Mesopotamians. This contact led to the spread of new ideas and technologies throughout the ancient world. Many of the most important scientific and mathematical discoveries of the ancient world were made during the Hellenistic period. For example, Euclid, who was a Greek mathematician, wrote a book called Elements. This book laid the foundation for geometry and is still used as a textbook today. Archimedes, who was a Greek inventor and engineer, developed many important principles of physics and mechanics. He's best known for his work on levers and pulleys, but he also developed a number of other inventions, including a type of helicopter. These inventions were shared with the rest of the world during the Hellenistic period, and they had a major impact on the development of science and technology. Unfortunately, most of the actual devices created during the Hellenistic period have been lost. This is because most of the people who lived during this time were not interested in creating machines for posterity. Instead, they were interested in creating machines that would help them in their everyday lives. For example, Archimedes was interested in developing machines that would help him build his inventions. So he wouldn't have been interested in creating a machine like the Antikythera Mechanism. Even though most of the actual devices created during the Hellenistic period have been lost, there are some surviving descriptions of these devices. These descriptions give us an idea of the types of machines that were being developed during this time. And one of the machines that was being developed was a type of calculator. This calculator was described by Hero of Alexandria, who was a Greek engineer and mathematician. He described a device that used a series of gears to perform calculations. This device was very similar to the Antikythera Mechanism. In fact, some people believe that the Antikythera Mechanism was actually created during the Hellenistic period and that it was inspired by Hero's calculator. However, there's no real evidence to support this theory, so it's still up for debate. So why doesn't any other ancient civilization have left mechanical artifacts like this one? Well, the truth is that the Antikythera Mechanism is unique. There's nothing else quite like it in the ancient world. It is true that there are some similarities between the Antikythera Mechanism and some ancient Chinese and Indian inventions. But those are just similarities in appearance. The Antikythera Mechanism is a far more advanced device than anything else known from the ancient world. It takes a high level of technological sophistication to create something like the Antikythera Mechanism. And there's no evidence that any other civilization had this level of technology. So the answer to the question of whether or not there was a civilization even older than Greece that invented something similar to the Antikythera Mechanism is probably no. The Antikythera Mechanism is truly one of a kind. But what do you think? Do you think that there was a civilization even older than Greece that invented something like the Antikythera Mechanism? Let me know your thoughts in the comments below. And as always, thanks so much for watching. When you think of ancient Greek inventions, what comes to mind? Maybe the Olympics, maybe the Arch-OK fair. But the ancient Greeks are also responsible for inventing one of the world's first computers, and that invention has had an outsized impact on modern engineering. And no, it wasn't Plato with his Academy or Aristotle with his Lyceum. It was an anonymous inventor around 200 BC who created something called the Antikythera Mechanism. This complex piece of machinery is named after the wreckage of an ancient Roman ship where it was discovered in 1902 off the coast of the Greek island of Antikythera. Originally, experts thought it was just another busted piece of Roman junk until they realized it was actually a sophisticated analog computer from 2 centuries earlier. The Antikythera Mechanism had many practical uses. It could track the phases of the moon, predict eclipses, and track the time of day down to the second. It was also an exceptionally advanced piece of engineering. Inside its bronze shell were at least 30 bronze gears made by cutting extremely thin sheets of metal and shaping them into place with a punch and a hammer. These gears are so incredibly precise that if you were to replace the gears in your iPhone with the Antikythera S gears, it would still work perfectly. They're also the earliest known example of what engineers call an epicycloid gear train, which is a system of gears that uses an additional gear called an annulus to modify the speed and motion of other gears. Epicycloid gear trains are everywhere today. The Antikythera Mechanism is also an example of what engineers call a differential, which allows 2 rotating shafts to rotate in opposite directions while sharing a single gear. Differentials are also everywhere today, like in cars. In fact, Many engineers who see the Antikythera mechanism for the first time assume that it is not all that impressive because they see the similarities between it and modern gears. To them, it looks like a very basic set of tools put together in an unnecessarily complicated way. Why make one gear when you can make 30 gears? But there's more to the Antikythera than meets the eye. You see, while we understand that this device is made up of gears, we don't actually know how these gears fit together and interact. This is partly because the device was waterlogged for hundreds of years, which eroded away some of the key components. It's also partly because even though we have figured out the general layout of the mechanism, there are still some unknowns about exactly how it functions. There are a number of different proposed reconstructions, but because the device is so fragmented, none of them are perfect. And here's where things get weird. In the early 1900s, the prevailing theory was that the Antikythera was basically a glorified calendar, basically a fancy way of tracking the phases of the moon. But over the last couple of decades, new discoveries have suggested that the Antikythera may have been far more capable than previously thought. For example, in 2006, researchers used X-ray technology to peer inside the mechanism and discovered that it contained 28 separate gear wheels, not just a few. By analyzing the pattern of corrosion marks left behind on the device's fragments, they were able to determine that the wheels fit together in a continuous loop, which allowed them to reconstruct the Antikythera's basic geometry. In 2014, researchers found evidence that the Antikythera had the ability to track the cycles of 5 planets, including Mercury and Venus, which orbit the Sun and not the Earth. Because of this discovery, the Antikythera was renamed the greatest clockwork device ever known from antiquity. It's important to note that we don't know how the Antikythera got this advanced. It could be that its creators simply stole ideas from much older devices like Hero's automata. Or it could be that ancient Greek scientists independently invented the same thing. But either way, the fact that such advanced machinery existed so early in human history is shocking. So who was responsible for this incredible feat of engineering? Well, unfortunately, we may never know. While we know that the Antikythera was built around 200 BC, we don't know who built it. In fact, we don't know anything about the society that created it except that it was destroyed when the Roman ship carrying it sank. Now, before the 1900s, most historians believe that the Antikythera was a piece of Roman technology. This was mostly because people back then just didn't believe that ancient Greeks could have possibly come up with such an advanced piece of machinery. But recent evidence suggests that the Antikythera was actually made by the Kingdom of Pergamon, which was located in what is now Western Turkey. This is based largely on stylistic analysis of the different parts of the Antikythera, especially the gears, which indicate a common origin. Now, the Kingdom of Pergamon was known to produce high-quality bronze objects, but despite their skill in metalworking, it still seems unlikely that they were able to produce a device as sophisticated as the Antikythera. For this reason, many scholars now believe that the Antikythera was actually created by Alexanders of Alexandria, who were known throughout the ancient world for their craftsmanship and mechanical skills. Scholars debate whether the Antikythera was intended to be used as a teaching tool, an astronomical research instrument, or something else entirely. But regardless of what it was used for, it's clear that it wouldn't have been possible without a substantial investment in research and development. In fact, some scholars estimate that creating the Antikythera required tens of thousands of hours of work. Unfortunately, little is known about life in ancient Alexandria, so we may never know who exactly was behind this incredible machine. Now, while we may not know who invented the Antikythera, we do know that when it was rediscovered in the early 1900s, it taught modern engineers some valuable lessons. One lesson that engineers take away from the Antikythera is that you don't need a computer to solve every problem. After all, the Antikythera doesn't need any electricity or programming to tell the time or track the phases of the moon. In fact, it's more accurate than many modern clocks. Of course, computers are essential for modern life, but the Antikythera is a reminder that sometimes simple solutions are best. Another lesson that engineers take away from the Antikythera is that complex problems can often be solved with simple tools. The Antikythera was made with nothing more than bronze and iron, yet it performs calculations that would take a modern computer by storm. In fact, it's believed that the Antikythera was capable of calculating the date of the next Olympic Games, a task that stumped even the most advanced calculators of the time. The The Antikythera is also an object lesson in the power of scientific thinking. It was clearly created by someone who understood the principles of astronomy and mathematics, but it was also created by someone who was willing to ask questions and explore the unknown. Without this combination of knowledge and curiosity, the Antikythera would never have been possible. Finally, the Antikythera teaches us that the ancient Greeks were far more advanced than we give them credit for. For centuries, the ancient Greeks were seen as a primitive society, and their science was often dismissed as unsophisticated. However, the Antikythera shows that the ancient Greeks were capable of making incredibly complex machines, and it's just one example of their advanced engineering. In fact, the Antikythera is still one of the most sophisticated pieces of machinery from antiquity, and it continues to influence engineers today. Many of the gear systems used in the Antikythera are still used in modern machinery, and its basic design has been replicated in everything from robots to satellites. And that's why when you look at the Antikythera mechanism, it's hard not to be impressed by the ingenuity and creativity of its inventors. It's a testament to the power of the human mind and the endless possibilities of engineering. Whether you're an engineer or just someone who loves science and technology, the Antikythera mechanism is sure to amaze you. It's a reminder that the ancient world was far more advanced than we often give it credit for, and that the Greeks were capable of some truly remarkable feats of engineering. If you want to learn more about the Antikythera mechanism, there are plenty of resources available. You can read about it online or watch documentaries about its discovery and restoration. You can even buy replicas of the Antikythera mechanism and try to figure out how it works for yourself. No matter how you choose to learn more about it, you're sure to be impressed by this amazing piece of history. The greatest inventions are sometimes also the most mysterious. We can think of things like the Antikythera mechanism, an amazing piece of technology that is so advanced it left scientists puzzled. It's unlike anything else they've ever seen before. But how did such an intricate device get lost to time? And why haven't we found others like it? The Antikythera mechanism is one of the oldest computers ever created, which makes it incredibly valuable to historians and archaeologists. They believe that it could have been used for astronomical calculations, though exactly what it was used for is still up for debate. Some say it had practical uses, while others claim it may have even been used to tell fortunes or predict eclipses. Its true purpose may be forever lost, but its existence is a remarkable discovery. It was discovered in 1901 by a sponge diver off the coast of the Greek island of Antikythera. He noticed some gears at the bottom of the sea and didn't realize at first that he stumbled upon something so important. The device ended up being so significant that the year it was found became known as the Year of the Mechanism. It was initially thought to be around 600 years old, but it's now believed to be twice that age. This would make its creation date back to between 200 BC and 70 BC, during a time when great inventions were being made all over the world. But if this thing was so special, why did we stop making them? The most obvious explanation is that this was an isolated incident. Perhaps there was an earthquake or a flood that wiped out any other similar devices. After all, it was underwater for nearly 2,000 years before it was found. Maybe something happened to cause its creators to abandon their work or to hide it away, never to be seen again. Whatever the reason, it seems unlikely that they would have continued creating these machines after a disaster like that. But we do know that the Antikythera mechanism wasn't the only complex machine created by the ancient Greeks. There were other inventions that remained in use for centuries. So why don't we see more evidence of these today? One of the main reasons could be wars and invasions. As history shows us, there have been many times when entire civilizations were wiped out because of conflict. If the people who built this device were wiped out, it's likely that their inventions were lost as well. Who knows how many other incredible devices were destroyed in battle or simply lost as time went on. Some scientists even go as far as to say that this device might have actually been created by another lost civilization, one that predates even the Greek Empire. These people may have been wiped out by the Greeks, or perhaps they were taken out by invaders from the north. Either way, the truth may never be known. What we do know is that when the Romans invaded Greece, they weren't exactly respectful of other cultures. Many of their gods were killed or replaced with Roman deities. Temples were torn down and books were burned. It wasn't uncommon for the Romans to destroy artifacts from other cultures just because they were different. This means that even if something like the Antikythera mechanism existed, there's a good chance the Romans would have destroyed it. The interesting thing is that this wasn't the first time something like this happened either. When Christianity began to take over Europe, many pagan texts and artifacts were destroyed. People were pressured to convert, and anyone who didn't was often persecuted. Some believe that this pressure to convert caused the destruction of many ancient devices that couldn't be explained by modern science. There are stories of ancient machines being found by farmers or construction workers who then reported them to the church. From there, the devices were taken and never heard from again. It's not certain what happened to them, but it's likely that they were destroyed so no one would be tempted to worship false gods. After all, the Bible warns its followers not to bow down to images or idols. So anything that appeared to be too advanced or too magical was probably considered a threat. The idea that ancient people had access to advanced technology would go against everything the church stood for. And those in charge were quick to crack down on anything that could potentially be seen as heresy. This raises another question, though. What if they didn't destroy it? What if someone else came across the Antikythera Mechanism and decided that it was simply too advanced to be real? Later civilizations may not have understood the value of these inventions, no matter how important they were to our history. When the device was found in 1901, it took experts years just to figure out what it was. Even today, there are many questions about its origins and its purpose. So it's easy to imagine how those who found it long ago may have assumed it was nothing more than a pile of scrap metal. To them, it may have looked like a useless piece of junk, even though it could have been one of the most valuable artifacts ever discovered. It's hard to believe that anyone would be so ignorant as to destroy something so important, but it has happened before. Many ancient tools and weapons have been found in places like Egypt and Greece, but there are always skeptics who claim they were planted there recently. Some even go as far as to say that the Egyptian pyramids weren't built by slaves, but rather modern tourists who snuck into the area and built them for fun. Of course, this isn't true, but it shows that even today, some people struggle to believe that ancient humans could have accomplished such amazing things. So it's possible that early explorers didn't understand the importance of these devices and discarded them like trash. Maybe they were melted down and used to make other objects. Or perhaps they were simply thrown in a fire and forgotten about. However, there is evidence that people did understand the importance of some ancient machines. Take the Baghdad battery, for example, an artifact found in Iraq that's believed to be one of the earliest forms of a battery. It was discovered in 1936, and at first, experts thought it was a vase. But as they studied it further, they realized it was actually a battery. It's believed to have been created sometime before 250 AD and was likely used for electroplating or maybe even to power small devices. To this day, nobody is sure what it was used for, but it shows that ancient people did understand the power of electricity and how to harness it. If they had the knowledge to create batteries, then maybe they also knew about the Antikythera Mechanism and how to use it. Maybe they saw it as a dangerous tool that shouldn't be messed with. After all, it was likely very complicated and they wouldn't have known how to fix it if it broke. So it's possible that they hid it away somewhere or destroyed it so it wouldn't fall into the wrong hands. But we may never know for sure. The truth is that the disappearance of the Antikythera Mechanism is a mystery that will likely never be solved. There are many theories, but without more evidence, we'll never know what really happened. It's safe to say that this device was truly amazing and that whoever created it was a genius. But it's also possible that there were others like it and that they simply disappeared over time. Maybe they were lost in the same way that the Baghdad battery was forgotten, simply because people didn't understand what they were or how to use them. Whatever the case may be, we can be sure that these ancient devices are a testament to the ingenuity of our ancestors. And as we continue to explore the world, we may find others that will baffle scientists for years to come. For now, the Antikythera Mechanism remains one of the greatest mysteries of the ancient world. And it's a reminder that there's still so much we don't know about our past. But as we learn more, we may find that this is just the tip of the iceberg. The mysterious Antikythera Mechanism has been baffling scientists for years. Ancient alien theorists are convinced it's proof that extraterrestrials once visited Earth. But could there be another explanation? Could this device be evidence of a lost advanced civilization that predates our own? And if so, how does it fit into the grand scheme of things? Ancient alien theorists believe that many of humanity's greatest mysteries can be explained by the theory that aliens once visited Earth. Some take it a step further, arguing that extraterrestrials may have even influenced the course of human history. The Antikythera mechanism is one such mystery that has captured their attention. Dating back to the 1st century BC, this complex device was discovered in a shipwreck off the coast of the Greek island of Antikythera, hence its name. It consists of a series of gears and dials that are used to track astronomical positions, including those of the moon, planets, and the Olympic Games. This level of sophistication is what makes the Antikythera mechanism so remarkable. Many ancient alien theorists argue that the complexity of the device points to an extraterrestrial origin. They suggest that the device may have been left behind by an advanced alien civilization that visited Earth in the distant past. Proponents of this theory point to the fact that the mechanism is thousands of years old, and yet it exhibits a level of complexity that was not seen again until the Middle Ages. They argue that there is no way that ancient humans would have been able to create such a sophisticated device without the help of an advanced alien race. But there is another possibility that ancient alien theorists do not consider: a lost advanced civilization. Humans have always strived to understand the world around them, and in the process, they have created some truly remarkable things. However, not all of these creations have stood the test of time. Many ancient civilizations created advanced technologies that were lost to history, either due to natural disasters, wars, or simply because they were forgotten over time. One such civilization was the Indus Valley Civilization, which flourished in what is now Pakistan and northwest India between 2800 and 1900 BCE. The Indus people were highly advanced for their time. They had developed sophisticated systems of agriculture, trade, and urban planning. They also created some remarkable works of art and architecture, including the Great Bath at Mohenjo-daro and the intricate carvings at Harappa. But for reasons that are not fully understood, the Indus Valley Civilization collapsed in the 1900s BCE. Its cities were abandoned, and its people migrated elsewhere. As a result, much of their culture and technology was lost to history. It is possible that the Indus people created advanced technologies that we have yet to discover. These technologies may have included devices similar to the Antikythera mechanism, but they may have also included other things such as advanced tools, weapons, or even machines. Unfortunately, we will likely never know what these technologies were or how advanced they were. But here's the thing: if a lost advanced civilization did exist, why haven't we found any evidence of it yet? Mainstream historians argue that there is no evidence of a lost advanced civilization that created devices like the Antikythera mechanism. They believe that the device was created by the Greeks, who were known for their advanced knowledge of mathematics, astronomy, and engineering. According to this view, the Antikythera mechanism was simply an extremely sophisticated device for its time and not evidence of an advanced civilization from beyond our world. One of the main reasons why mainstream historians reject the theory of a lost advanced civilization is the lack of evidence. There is no archaeological evidence of a civilization that was advanced enough to create the Antikythera mechanism. Additionally, there are no written records or other artifacts that provide evidence of such a civilization. Without concrete evidence, it is difficult to prove the existence of a lost advanced civilization. Another reason why mainstream historians reject this theory is that it contradicts the established historical narrative. The current historical narrative is based on the belief that human civilization has progressed in a linear fashion. This means that early civilizations were less advanced than modern civilizations. A lost advanced civilization would challenge this narrative and require a reevaluation of everything we know about human history. This is a daunting task, and it is understandable why mainstream historians are reluctant to embrace this theory. Finally, mainstream historians argue that the Antikythera mechanism is simply too complex to have been created by an ancient civilization. They believe that the device required a high level of technical knowledge that was not available to ancient people. For example, the Antikythera mechanism uses a series of gears and pinions to track astronomical positions. This is a highly complex system that requires precise engineering and machining. Mainstream historians argue that ancient civilizations did not have the technology necessary to create such a complex system. So what's the real story behind the Antikythera mechanism? Well, that's where things get really interesting. Number 3. Lost knowledge. There is a growing body of evidence that suggests that ancient humans may have possessed knowledge that is far more advanced than we previously thought possible. This is not to say that ancient humans were on the same level as modern scientists and engineers, but rather that they may have had access to technologies and ideas that we have yet to discover. For example, the Antikythera Mechanism demonstrates an advanced understanding of astronomy and engineering. It is possible that ancient humans possessed other devices like the Antikythera Mechanism that we have yet to discover. If so, this would suggest that ancient humans were more advanced than we previously thought. But where did this advanced knowledge come from? One possibility is that ancient humans learned this knowledge from extraterrestrials who visited Earth in the distant past. While this is a popular theory among ancient alien enthusiasts, it lacks concrete evidence. However, it is an intriguing idea that cannot be completely ruled out. Another possibility is that ancient humans acquired this knowledge through other means. For example, ancient humans may have discovered advanced technologies left behind by previous civilizations. It is also possible that ancient humans made these discoveries independently, perhaps through trial and error or by observing the natural world around them. Whatever the case may be, the Antikythera Mechanism and other similar devices suggest that ancient humans may have possessed a higher level of knowledge than we previously thought possible. Number 2. Uncanny precision. The Antikythera Mechanism is a testament to the ingenuity of ancient humans. Its construction is incredibly precise, and its ability to track astronomical positions is still impressive today. But what is perhaps most remarkable about the Antikythera Mechanism is the level of precision with which it was made. The device is made up of a series of gears and dials that are incredibly precise. The gears are so finely machined that they can rotate smoothly for centuries without breaking down. The dials are also incredibly precise and can measure the positions of celestial objects with great accuracy. This level of precision is what makes the Antikythera Mechanism so remarkable. To put this into perspective, the Antikythera Mechanism was created in the 1st century BC, while the first computer with comparable computational power was not built until the mid-20th century. The fact that ancient humans were able to create such a precise device without the aid of modern tools and technology is truly remarkable. It is possible that ancient humans possessed other devices with similar levels of precision, but we have yet to discover them. If so, this would suggest that ancient humans were even more advanced than we previously thought. But why don't mainstream historians accept this possibility? Mainstream historians argue that the precision of the Antikythera Mechanism can be explained by the skills of ancient Greek craftsmen. They believe that the Greeks were highly skilled engineers and astronomers, and that they were able to create the Antikythera Mechanism through trial and error. However, this explanation does not account for the level of precision involved in creating such a device. The Greeks were skilled craftsmen, but it is unlikely that they were able to achieve the level of precision required to create the Antikythera Mechanism without the aid of advanced tools or technology. This leaves us with more questions than answers. Did ancient humans possess advanced tools or technology that we have yet to discover? Or were the Greeks able to achieve a level of precision that we thought impossible? Number 1. Why they don't want you to know. The truth is that there are many compelling reasons why the mainstream may not want you to know about the Antikythera Mechanism and other similar devices. First and foremost, the discovery of these devices challenges the long-held belief that human civilization has progressed in a linear fashion. If ancient humans were more advanced than we previously thought, it would call into question everything we know about human history. Furthermore, the discovery of these devices would suggest that ancient humans may have possessed knowledge that we have yet to discover. This would challenge the current state of scientific and historical research and could lead to a complete reevaluation of our understanding of the past. In addition, the discovery of these devices could potentially lead to the discovery of other ancient technologies that we have yet to uncover. This could revolutionize our understanding of ancient cultures and could lead to the discovery of new technologies that we can use today. Finally, the discovery of these devices could have a profound impact on society as a whole. If ancient humans were more advanced than we thought, it would suggest that we may be capable of even greater things than we currently believe. It could inspire a new generation of scientists and historians to push the boundaries of human knowledge and exploration. The possibility that ancient humans were more advanced than we thought is a controversial topic that challenges our understanding of the past. While mainstream historians may not want you to know about the Antikythera Mechanism and other similar devices, it is important to keep an open mind and explore all possibilities. After all, We can never be truly sure of what ancient humans were capable of, and we should not dismiss any evidence that could shed light on our past. The Antikythera Mechanism is one of the most important archaeological finds of the 20th century. It is considered to be the world's first computer, and it was created by the ancient Greeks around 200 BC. But what else might we discover about this mysterious device and its creators in the future? Join us as we explore the possibilities. One of the most exciting things about the Antikythera Mechanism is that it may not have been the only one of its kind. This bronze device was found in an ancient shipwreck off the coast of the Greek island of Antikythera, hence its name. The wreck is believed to have sunk sometime around 80 BC, and archaeologists have found evidence that it was carrying cargo from Egypt to Greece. One of those artifacts was the Antikythera Mechanism, which was created around 200 BC during the Hellenistic period. This was a time when the Greek kingdoms were at the height of their power and influence, and they had a deep interest in astronomy, mathematics, and engineering. They were also very familiar with the teachings of Plato and Aristotle, who believed that the universe was made up of 5 elements: earth, air, fire, water, and ether. The Antikythera Mechanism is thought to have been used to track the movements of the planets and stars in the sky, as well as to predict astronomical events such as eclipses and the Olympic Games. It was also used to tell the time, keep track of dates, and calculate the phases of the moon. The mechanism was incredibly complex for its time, consisting of 30 bronze gears arranged on 3 main shafts. It was housed in a wooden box decorated with scenes from Greek mythology and controlled with a series of dials and pointers. Despite its complexity, the mechanism was surprisingly accurate, able to track the movements of the planets within a few minutes of the actual astronomical events. But here's the thing, it may not have been the only one of its kind. After all, we don't know exactly how many mechanisms like this there were, or if they were common tools used by astronomers and mathematicians across the Greek kingdoms. Maybe there are more of them buried beneath the ocean floor or lost to time, and new technologies may help us find them. One of the most exciting developments in the field of archaeology is the advent of new underwater excavation technologies. These new techniques allow archaeologists to explore deeper waters and recover artifacts that were previously out of reach. For example, remote-operated vehicles, or ROVs, can be used to explore shipwrecks at depths of up to 10,000 feet without the need for divers. ROVs are equipped with cameras, lights, and manipulators that allow researchers to observe and collect artifacts from the seabed. In addition, unmanned surface vessels, or USVs, can be used to monitor and collect data from larger areas of the ocean floor. These vessels are equipped with sonar, which allows them to create maps of the seafloor and identify potential sites of interest. By using these new technologies, archaeologists can access areas of the ocean floor that were previously inaccessible and recover artifacts that would otherwise be lost to time. But what does this mean for the search for the Antikythera Mechanism too? Well, it means that we may be closer to finding other mechanisms like this than we think. The Antikythera Mechanism was discovered in the Antikythera wreck, a Roman cargo ship that sank off the coast of Greece in 80 BC. The wreck is located at a depth of about 150 feet, which makes it challenging to explore. However, with the advent of new underwater excavation technologies such as ROVs and USVs, archaeologists may be able to explore the wreck in greater detail and recover additional artifacts that may shed light on the creation and use of the Antikythera Mechanism. Additionally, these technologies may also help archaeologists locate other shipwrecks that may have been carrying similar devices. For example, the Black Sea Maritime Archaeology Project has used USVs and ROVs to explore a number of shipwrecks in the Black Sea dating back to the time of the Antikythera Mechanism. One of the most promising sites is the Ulyaborlu ship, which dates back to the 4th century BC. It is thought to have been carrying a cargo of luxury goods from Greece to the Black Sea coast when it sank. The goods included jewelry, perfume, and bronze objects, some of which may have been related to astronomy or mathematics. While the Ulu-Buran wreck has not yet yielded any direct evidence of the Antikythera Mechanism or similar devices, the advent of new underwater excavation technologies may change that. Archaeologists may be able to explore the wreck in greater detail and recover additional artifacts that could shed light on the use of bronze in ancient shipbuilding and trade networks. Researchers are still working to decipher the secrets of this ancient device and its creators. For example, the mechanism has been studied using X-ray and computed tomography scans, which have revealed the intricate details of its construction. Scientists are also using advanced imaging techniques to create 3D models of the mechanism, which will allow them to study it from all angles and even virtually disassemble it to see how it works. Another exciting development is the use of artificial intelligence, or AI, to decipher the inscriptions on the mechanism. The mechanism has several inscriptions that describe the astronomical phenomena it tracks, but they have been so damaged by corrosion that they are difficult to read. However, recent advances in AI technology have made it possible to train a computer to recognize patterns in the damaged text and fill in the gaps. This could unlock new insights into the astronomical knowledge of the ancient Greeks and the purpose of the mechanism itself. We've already learned a lot from studying the Antikythera Mechanism. For example, it has taught us about the astronomical knowledge of the ancient Greeks and their ability to create complex mechanical devices. It has also provided insights into the economic and cultural exchanges between the Greek kingdoms and the rest of the Mediterranean world. But there is still much more to learn, and future discoveries may revolutionize our understanding of ancient Greece. For example, scientists are currently working to determine the exact origin of the mechanism. The prevailing theory is that it was made in Greece, but some scholars believe it may have been produced in Egypt or some other part of the Mediterranean. Future discoveries may shed light on the cultural and technological exchanges that took place among the different civilizations of the ancient world and help us better understand the contributions of each to the development of human civilization. Additionally, scientists are also working to determine the full range of uses for the Antikythera mechanism. We know that it was used for astronomical calculations, but it may have had other applications as well. For example, it could have been used for agricultural planning or to track the progress of ships at sea. Further research may reveal new uses for the mechanism and provide insights into the ingenuity of the ancient Greek mind. Speaking of ingenuity, there's no telling what else we might uncover about ancient Greek technology in the coming years. We've already discovered evidence of advanced tools and weapons that challenge our traditional view of ancient Greek society. For example, we know that the ancient Greeks were skilled metalworkers and produced some of the finest weapons and tools of the ancient world. But recent discoveries have revealed the existence of even more sophisticated tools and weapons that push the boundaries of what we thought was possible during that time period. For example, the discovery of a bronze sword in the Greek island of Crete has revealed a level of craftsmanship that was previously unknown. The sword is over 3,000 years old and features an intricate design that shows a high level of skill and precision. Similarly, the discovery of a bronze spearhead in the Peloponnese has revealed a new type of weapon that was not previously known to have existed in ancient Greece. The spearhead is over 4,000 years old and features a unique shape that would have made it extremely effective in battle. These discoveries challenge our traditional view of ancient Greek technology and suggest that the ancient Greeks were even more advanced than we previously thought. As we continue to learn more about ancient Greek technology, we may discover new ways in which it influenced the development of modern civilization. For example, we know that the ancient Greeks were pioneers in the field of engineering and built some of the most impressive structures of the ancient world, such as the Temple of Zeus at Olympia and the Mausoleum at Halicarnassus. But recent discoveries have revealed the existence of even more sophisticated structures that push the boundaries of what we thought was possible during that time period. For example, the discovery of a large circular structure in the ancient Greek city of Delphi has revealed a level of engineering that was previously unknown. The structure is over 2,000 years old and features a series of tunnels and chambers that were used for religious rituals. Similarly, the discovery of a network of underground tunnels in the ancient Greek city of Athens has revealed a new level of sophistication in ancient Greek urban planning. The tunnels were used for drainage and sewage disposal and are some of the earliest examples of this type of infrastructure in the ancient world. These discoveries challenge our traditional view of ancient Greek technology and suggest that the ancient Greeks were even more advanced than we previously thought. And as we learn more about ancient Greek technology, we may discover new ways in which it influenced the development of modern civilization. Who knows what wonders we might find in the next century of archaeological research? Perhaps we will uncover evidence of an entire civilization that existed before the Greeks, and whose advanced technology was responsible for many of the incredible artifacts that have been found. Or maybe we will find evidence of trade routes connecting the Greeks to other advanced civilizations around the world. Whatever we find, one thing is certain: the future of archaeology is bright, and we are only just beginning to scratch the surface of what is out there to be discovered. But what do you think? What lessons do you take away from the Antikythera mechanism? Let us know in the comments below. Also, if you have a topic you'd like to see covered in a future episode, just leave a comment below and it might be selected. And don't forget to subscribe for more videos like this one. Until next time, stay curious.